Welcome back to the channel, you curd nerds. We've got yet another mock check ride, but this one's an instrument one, so don't click away. All right, this one's new material. I know we've been covering a lot of private pilot mock check rides, but here's the thing: if you're gonna be a pilot, 99% of the time you got to make it through private pilot. So that's why we got so many private pilot mock check rides, because anybody who's gonna go fly an airplane has got to get through that mark. But this instrument mock check ride, this student killed it. All right. I didn't really add much to it because this student knew the answers. They went in depth on covering the topic, covering the subject, covering the answers. So I didn't have to dig any deeper. This student rocked it. There wasn't really a whole lot I could add to it. Right at the end of it, we covered a couple obscure things where we had to go find an FAA order that covered some specifics about instrument approaches. But this student did absolutely amazing, and I would have been more than happy to sign them off to go take their check ride at the end of this. So enjoy it. Let me know if you have any questions. Are you okay with me recording this mock check ride to be used for social media, whether it be Instagram, YouTube, TikTok, Facebook, Reels, etc.?
Absolutely.
Awesome. So before just jumping right into it, why don't you tell me a little bit about like where you're training, what you're doing for your training? I know you sent me a POH, and for instrument, you're already a private pilot. I'm assuming you know how to read a POH. All right, so we're not going to dig too much into systems like specifically for your aircraft, but tell us a little bit about your training. What kind of got you to this point?
Sure. So I started back in maybe mid-August. My name's Thomas, by the way. Really appreciate you taking the time to do this. I train out of school out of Pompano Beach Air Park. It's called American Flyers. Really phenomenal school. They really focused on a lot of pencil and paper in the beginning. So I actually still don't really use ForeFlight or anything. A lot of it is paper flight plans. I sent you both so that you could see it. Like it was a little ForeFlight diagram of the flight plan. I did my private with them, and I've been going pretty much full time, but I do work part time while I'm in school as well. So I finished up my privates on mid-December, and then I started instruments the beginning of the year, and there's been probably about a month since I finished the actual instrument course. We've just been kind of waiting on DPs. There's a little bit of a shortage down here, and trying to get the right one. So a guy's finally flying up from Homestead, and he's coming up next week. So I have my instrument tech ride on Wednesday, and I feel pretty good about it. I feel way more confident than private. Private, I did well, but it was definitely like drinking from a fire hose. And I actually feel confident and competent in comparison with instrument. I've actually really enjoyed it. I personally like that it's a little bit more black and white, and that you follow like the procedures, and that there's a specific climb gradient and turn rate of turn and everything like that. So I've been enjoying instrument. It's part of a dual part 141 program, so I actually am meeting my commercial requirements at the same time and should be able to do that tech ride in about a month.
Oh, I absolutely love it when schools do that, because it saves people so much money. And, I definitely felt the same way when it came to instrument. Private pilot, yeah, it's drinking through a fire hose and you're just hanging on for dear life, right? And then when you get to instrument, you're like, well, I know how to fly an airplane. And the instructor usually starts treating you a little bit more like a human being instead of a student that's trying to kill them.
Yeah.
So it definitely feels nice. Now, how much in the way, I see you down in the Panhandle, or no, that's not the Panhandle. Either way, I see you down in Florida. How much actual IFR have you gotten throughout all of your instrument training?
Very fortunately, my IFR 100s up to Melbourne were both actual IFR days. Oh. And it was like a freak thing. We normally don't get much IFR at all. I think I might have more actual IFR logged than some of the instructors at my school.
I mean,
maybe a total of 5 hours at this point or something. But it is pretty uncommon. I think since starting flight school, I've only canceled maybe 3 flights total. You can pretty much fly every day here.
That is awesome. I know by the time I was an instructor, I had like 0.3 actual IFR, and it was a sandstorm.
Oh, wow.
Because I did all of my training in Arizona. So
okay.
It's a little different, but how big of a difference is like, because I'm assuming you've done like Foggles or Hood, or nobody uses like the Icarus product because that thing's just so expensive. But how big of a difference was it for you?
Because of how much night flying I had to do here right after getting my private pilot, it didn't feel that different. So I don't really like flying with the Foggles, but right after I got my private, I think for about 2 months, the only solo times I got were at night. Oh. And so that made it feel not too much different, because a lot of times I'd be flying out over the Everglades and the horizon would be pretty obscured. And there are like just a few lights out there. So actually, that I think prepped me more than training under the hood.
I believe it. I know when I start like the second block of IFR training for most of my instrument students, it's a night cross country, and I try to aim for like abyss, no cities, just middle of nowhere. Because again, technically it's VFR, but as you noticed, right?
Right, but if you can't fly with reference to the horizon,
yep,
that's all it takes.
So, I like to go through the same little script. You probably saw the videos, whether it be on YouTube or Instagram, etc. I go through the same kind of a script that a DPE would go through. Okay. Mm-hmm. They're going to ask for all your logbooks, your documents, etc. Right. Advisory Circular 6165H is going to be all the endorsements that you need to go take this check ride. Right. If you really want to look it up, it's in the appendix in the back. You need, your pilot certificate, medical certificate. You don't need your logbook anymore, right? Because you don't actually need it, but bring it, right? Because how else are they going to put it in your logbook? And then there's 3 outcomes to every check ride, right? There's satisfactory, unsatisfactory, and incomplete. Satisfactory is consistently within the standards. Perfection is not the goal, right? I hate the phrase practice makes perfect. No, practice makes progress. Okay. Right. And we're not looking for more progress on a check ride, but we're looking for a safe and efficient and adequate pilot. One that's not going to get anybody killed, one that's not going to get themselves killed, one that's not going to get a pilot deviation, right? Then we got unsatisfactory. This is consistently outside of the standards. Pilot deviations, just blatant disregard for safety. I bring up an incident that happened at UND. A student went out on solo. They didn't set their parking brake hard enough. And when they went to go do their after start checklist, the airplane rolled away and the prop chopped up another airplane. If that's on a check ride, obviously we're not going to pass that check ride. Now, I failed one of my instrument stage checks by losing situational awareness by not keeping track of DME. Nobody was in any danger, but I lost situational awareness and was unaware of it. I was completely lost. I had no idea where I was. Okay. Then we've got incomplete. This is things for like weather, safety of flight, aircraft airworthiness, unprepared. Well, unprepared pilot could very likely just be an unsatisfactory. The reg is 6143 Bravo that covers all of the appropriate reasons for an incomplete on a check ride. All right. Last thing a DPE is going to ask is, have you read the ACS and do you understand the standards that you're being held to? Yes. All right. That's their little cover their ass, because now it's like, well, I didn't know that was going to be on the test. Well, you said you read the book, right? So DP is going to probably offer like a 5-minute break at that point. You want to go get a glass of water or what have you. Have at it. Remember, it's your check ride to fail. If you got to go take a tinkle, if you need to go get some water, you need to go get a snack, say so. Okay. My final instrument check ride, the oral was 9 hours long. Wow. Yours is not going to be that way. There was underlying circumstances that led to that, but it got to a point where I'm just like, dude, I'm tired. Like, I'm done. Either fail me or let's move on.
Was it one area that you just kept digging in? Or?
No, what it was is I used my GI Bill to get all my flight training done. And the VA, the Veterans Affairs, sends a certain amount to the school. Mm-hmm. And I got through my instrument training so quickly that there was a big chunk of change still sitting in my account. So the examiner who was doing the check was trying to drain the account because it was just going to get sent back to the VA if it didn't get used.
Interesting. Okay.
So it is what I'm saying. There's underlying circumstances to that situation. But let's get right into it.
Absolutely.
First question I'd like to ask, when do you need an instrument rating?
So there's 4 different main areas that you would need an instrument rating. One is if you're going to be in Class A airspace, you have to be on an IFR plan. And to be on an IFR plan, you need to be instrument rated. The second is anytime that you're in less than VMC, visual meteorological conditions. So whenever there's IFR conditions, you need to be in an IFR flight plan, so need to be instrument rated for that. If you have a commercial license and you are going to be carrying passengers for an excess of 50 nautical miles or at night, then you're going to need to be instrument rated as well. And then lastly, if you're going to be in special VFR at night, then you need to be instrument rated.
All right. The only thing I want to add to that is PIC.
To act as PIC.
Yep, to act as PIC. Because here's the thing. I had a buddy that she went and got a ride in a Vision Jet as a private pilot. And the owner of the Vision Jet was an instructor. Well, she got to log it in Class Alpha. But she wasn't acting as PIC, right? I know that's a very obscure, but you remember multiple choice questions, right? Or multiple choice answers. The most correct answer would include PIC. Okay. Now, what about recency of experience? If I want to continue to act as a pilot in command, what do I need to get done, and in what time frame to ensure that I can maintain my instrument privileges?
Yeah, so there's a few things that apply just to being PIC in general, and then a few things that are specific for instrument. So in general, you're going to need to make sure that your flight review within the past 24 months has been done. That consists of an hour of ground training and an hour of flights. There's a few different things that can substitute for that. You also, within the past 90 days, need to have done 3 takeoffs and landings if you're going to be acting as PIC, with any passengers. If those are at night or with a tail wheel plane, then they need to be done also at night or to a full stop for both of those. And then specifically for instruments, you need to have done and logged 6 instrument approaches within the preceding 6 months, as well as holding, navigating, and intercepting and tracking via, I guess let me phrase that better. You need to be holding, intercepting, and tracking and using navigational aids solely by use of reference to the instrument.
Okay.
Preceding 6 months.
All right. Does this have to be in an airplane?
No, those can be in a certified flight simulator or airplane training device. If it's in a simulated device, then those simulated instrument conditions need to continue all the way down to the decision height or decision altitude. If you are in a plane, though, then you need to be in actual IMC at least until the final approach or the final segment, or with a safety pilot down to the decision height or decision altitude.
Awesome. Now, I love that you brought up logged as well. What's required to be logged? What do you have to put in your logbook?
You only have to log things that are required for recency, for currency. So, you can do 100 approaches within the past 6 months, but you really only need to show that you've done 6 to maintain the currency.
All right. Yeah. And directly in relation to IFR.
Correct.
Awesome. Now, let's say, I don't know, your airplane was broke, right? My airplane, the fuel bladder sprung a leak, and that took me months to replace. It was a terrible, people refer to it as an extremely religious experience trying to replace that fuel bladder. So let's say you were in the same shoes as me and you ended up not being able to fly for 6-7 months. What do you need to do now?
So if you are outside of your 6 months of currency, you do have 6 months of, let's say, a grace period where then you can become current again, either with the use of a safety pilot or, like I said, in the training device or the simulator. If you're outside of that 6-month grace period, then we're in a totally different situation, which I can go on into a second. So within, let's say you pass the first 6 months, even though you're in the 6-month grace period, you're not technically current. So you can't still enjoy the privileges of your instrument rating, but you can make up the 6 hits with the safety pilot or the training device.
Awesome. Awesome. Now, what's the minimum rating of that safety pilot?
Minimum rating is that they need to hold a private pilot license and be, let's say, type rated for the specific aircraft that you're in. So they need to know how to fly the aircraft, and for that aircraft needs to have dual control so that they can also take over.
Awesome. Awesome. None of those old Bonanza throwover controls, right?
Right.
Now,
I've never seen that in person.
Oh, I've seen it once, and it's like, that's funky. Like, I don't see like, if the other person actually needed those controls, like, y'all are screwed.
Right.
Like, awesome. Now, let's say, I don't know, we broke our leg and we couldn't fly for like a year and a half. What do I need to do now?
So, in a year and a half, you've passed the 6 months and the 6-month grace period. Now, you're completely not current, but you can do an instrument proficiency check. That can be done by a certified flight instructor. That can be done by an FAA examiner. If you're in the military, it can be done by someone certified as well, but that doesn't apply to me. That is within the farm exactly what is going to be covered, and I can go over those details if you'd like. Not everything can be done in the simulator for that, though.
Yep.
So it's a proficiency check that will then reinstate your currency.
Now, let's say you went and got your multi-engine instrument rating. Are you current again?
I believe that an instrument rating or check ride of sorts does constitute the currency requirements.
It does. It checks the box for IPC. Awesome. That's where a lot of people struggle. Now, we all remember the acronym Aviates. Can you tell me which portions of that acronym for the required inspection and maintenance, which ones of those are actually required for IFR?
Well, all of them are required for flight in general. The one that is specific to IFR is going to be the V, making sure that your VOR check has been done within the past 30 days. I would say another crucial one is probably your altimeter and pitot-static system check within the preceding 24 months. And those would probably be the two most crucial for IFR that I could think of.
Yep, those ones are definitely the two most they're applicable for IFR. My airplane's not rated for IFR because the attitude indicator's been broken. I don't do the VOR check, right? I look out the window, right? I also don't do the pitot-static system for IFR. There are two different pitot-static system checks that you can do. One specifically for IFR. Awesome. Now, let's say we're doing our pre-flight planning. When would I need to file an alternate?
Cool. So we're doing pre-flight planning. The way I've been thinking about it is that an alternate always has to be filed unless two conditions are simultaneously met. So the destination that you're going to has to have a published instrument approach. And then also within 1 hour before and after your estimated time of arrival, the conditions have to be at least 2,000 feet for the ceilings and 3 statute miles of visibility. So both of those conditions are met simultaneously, then you found a loophole. But otherwise, always file an alternate.
Always.
And honestly, I just try to have one just in case anyways. And being in South Florida, weather can change in like an hour.
Oh, yeah. And I mean, believe me, the one time I didn't file an IFR alternate, I wish I did. Oh, dear. It was a disaster. Yeah, it was a disaster. Maybe I'll tell you. If we have some time, I'll tell you all about it. Now, I'm looking through. Let's talk about some departure procedures. How do I know? What's the two different types of departure procedures first?
Yeah, so we could have obstacle departure procedures, and those will not require a clearance. Those will just be, let's say, climb gradients and for obstacles that may be in the vicinity of the airports. You can also have a standard instrument departure. That one you do need a clearance for. That's going to be to reduce basically the workload between ATC and pilots. And that might, include certain fixes and, VOR tracks, different things like that. Usually is a little bit more geared towards lost comms situations as well. So if something happens, you have a route to get to your in route phase. Whereas the ODP, it's a little bit more general. The ODP will just be either textual or graphical. From my understanding, I've just seen the textual in the TPP, whereas the SID is at least graphical.
Awesome.
Could be textual as well.
Right. Now, how do well, you kind of described it. All right. The only other thing you'd say is it says obstacles in the title, right? That's another great way to tell the difference. Awesome. I am happy with all of those. We'll talk about IFR altitudes in a little bit. Let's get into some instrumentations. Now I forget, are you glass or are you six-pack?
My school has a couple of glass cockpits, and I don't know if they're mainly for the full-time academy kids, but I haven't been able to get much time in them. So I actually will be doing the check ride in a six-pack. I've only flown G3X like 3 times. I only flew a G1000 once before my school actually kind of phased them out. I think they sold the 2 that we had.
Oh, G1000s are nice. What's a G3X?
To be honest, I couldn't really articulate the difference between the 2 because I didn't even really dig into the POH as much. It was like, I found out.
I see what it is. You're good. The G3X here. Let me show you my screen real quick, just so that you can get kind of an idea of what I'm talking about. Oh, look, it's not showing. There it is.
There we go.
So G3X, if we look at it, you've got your engine instrumentation, your radio, your attitude indicator, your moving map. I guess you can get a camera and synthetic vision and all kinds of other fancy things for them. A G1000, on the other hand, is 2 screens. Okay. So
that'd be an MFD technically.
Yeah. So you get a PFD and an MFD, and as you see, you got a lot more buttons. There's a whole lot more functionality in a G1000, what looks like a G3X. But I bet a G3X is cheaper. See, look, the display alone for a G1000 is $4,000.
Yeah, it's a little steep.
Awesome. All right, so we're going to talk specifically about 6-pack old gyroscopic vacuum-driven instrumentation, just because, well, that's what you're flying in. So let's start on some gyroscopic instruments. What are our 3 gyroscopic instruments?
So the first 2 are going to be based off of my vacuum pump system. The 2 that are gyroscopic are going to be my attitude indicator, my false horizon or artificial horizon, and then I have my direction heading indicator as well. The third one, which is not on the vacuum system, it's electric, is going to be my turn coordinator. So those 3 are all gyroscopic.
Awesome. What principle does the attitude indicator rely on? What gyroscopic principle is the attitude indicator functioning on?
The attitude indicator functions off of rigidity and space. That is going to be horizontal gyroscope, which basically stays level the same way that the horizon does, and then the plane moves around it.
Awesome. I love it. Have you ever heard the phrase pendulous vanes?
It rings a bell, but I haven't talked about it much myself to be able to articulate it.
And here's the thing. I worry about it because it used to be in the Pilot's Handbook of Aeronautical Knowledge and the Instrument Flying Handbook. It's not in there anymore, but I still bring it up because, let's be honest, some of these DPEs, They were here when they were dodging, they were dodging pterodactyls in the traffic pattern when they got their private pilot certificate. Like, no shame. It's just, they've been around for a while.
Yeah.
So pendulous vanes, I'll give you a brief little rundown on it just in case it gets brought up on your check ride. We know that air has to get pulled through the attitude indicator. That's how the vacuum system works, which means the air has to come out somewhere. Well, there's these little slits on the bottom of the shaft that the gyro sits on. Okay. Think almost like a Beyblade or like a top. Okay.
Okay.
So the air gets pulled through the gyro, down through this shaft, out through the slits at the bottom. Okay. And these slits at the bottom, it's just kind of held there on that gimbal that the attitude indicator rides in, or that the gyro rides in. Okay. So the air goes out of those slits. That's where it escapes the instrument and then escapes the case. It goes out of those slits. Now, if I was to block some of those slits, it would cause kind of like a on one side, which would kick the bottom of the attitude indicator. And we know that when we apply a torque to a spinning object with mass, it applies that force 90 degrees in the direction of rotation, right?
Right.
It's precession. But how do I actually plug up those vanes? Or how do I actually plug up those slits is with pendulous vanes. And what they're doing is they're reorienting the attitude indicator with gravity. Because as we said, it's rigid in space, meaning if I was to fly from the North Pole to the equator, I hope this isn't news to you, the Earth is round, the attitude indicator would be sideways, wouldn't it?
Right.
Well, pendulous vanes, what they do is they line up with gravity, and those little vanes block those holes where the air is coming out, and it causes it to give it that little jet, and then it jets 90 degrees direction of rotation, kicks the thing the appropriate direction.
Would that be in your POH to know whether or not that is happening in your plane?
I really doubt it's going to be in your POH. This is kind of like a generic, this is how attitude indicators work.
Oh, okay.
Right?
So this
is like across the board how attitude indicators work. I've taken apart a couple broken attitude indicators, and every single one I've taken apart has pendulous vanes in it.
Interesting.
All right,
okay.
unless it's an electrically driven one. If it's an electrically driven one, then it has an IRU that's used to like realign itself. But that's airline stuff. All right, and the only reason I bring it up is because I don't want you to go off and fail, because like they brought up something that's no longer in the book. And I literally just looked it up. So I'm like, all right, I'm doing an instrument one. Let me think of all the gotchas I had in my 9-hour oral. And pendulous vanes was one of them. And we opened it up to the book and it's like, look, there it is. And I went to try and find it. It's not there. Okay. Now let's talk about our heading indicator, which is, which direction is that heading indicator rotating, right? So you said the attitude indicator is rotating horizontally. What about the heading indicator?
Heading indicator will be vertical. I don't know if it's forward or back or if that matters.
I don't either. I guess it would change, wouldn't it? If it's going forward or back based on which side of it you're on, right?
That's true. That's true.
Now, how often should you be... Well, what phase of flight should you be readjusting your heading indicator if necessary?
So it's really only, your magnetic compass is really only accurate in straight and level flights, which is when you should then be readjusting the directional indicator to make sure that it matches, and at least every 15 minutes due to natural precession. So I can dive into that for a second, because since the Earth is rotating, that gyro is staying in place, and because of the rotation of the Earth, now after a certain amount of degrees that the Earth is rotated, it's no longer going to be accurate.
So that's not what precession is. You're thinking of lubber line, or the rum line, or something like that. This is just like from old. That's like way old school navigation. That's like how airliners used to navigate. Precession is that when you apply a torque to a spinning object with mass, it acts 90 degrees in the direction of rotation, right? So like when I'm banking an airplane, if my heading indicator is trying to stay flat, well, when I bank it, that's like me applying a torque to it and it wants to rotate 90 degrees direction of its rotation. Does that make sense? Oh, sorry. Attitude heading indicators up and down. So like when I bank, I'm applying a torque to the bottom of that gyro. It's turning. All right. We don't even cover that anymore. The fact that the Earth rotates, because like we use inertial reference units, we use GPS, we use magnetometers, we use so many other things that like make it so that we don't have to worry about that anymore. Is that
okay? So it's mainly due from banking, and then the precession effects that you would reset it. Okay.
Yep. That's why the old heading indicators precess a whole lot more. Right.
Yeah. Some of mine for this school that I'm at, I have to reset it like every 2 minutes and pretty much after every big turn.
Yep. When you're in a hold, you should probably check them at the very least on the inbound leg every time.
Yeah.
All right.
I've definitely had a few like that.
And, my attitude indicator, my airplane's failing, my heading indicator is failing. Like the thing is, they're useless at this point because they precess so much. Right. Now you brought up the compass. What are some of the concerns about that compass? Like, what are some of the errors and limitations of it?
Yeah. So there's a few different things, actually a multitude of things that can really affect your compass. One, you have deviation. So usually it'll be placarded or somewhere in the plane where the electrical equipment or things that are in the plane can throw off your magnetic detection. That's why you shouldn't set your iPod or phone right next to it.
Never made that mistake. I was saying I never made that mistake before.
Right. I did hear of one person who on a check ride, the DPE slyly put the phone next to it. To notice.
That's dirty.
A little evil to me. We've got variation as well, so need to be looking at those isogonic lines.
Yep, isogonic. Yep.
On the sectionals. Secondly, we can have oscillation errors. There are magnetic dip errors. We can have acceleration errors as well. So I can dive into the details of each one of those. Like normally, because of the counterweight on the magnet itself, if you are turning to the north, then you want to undershoot by, I want to say it's half your bank angle plus your latitude. So for here, it's usually like 23, 24 degrees. And then the opposite, the inverse for the south, you want to overshoot. And then if you're on an east or west heading, if you accelerate or decelerate, then that weight is going to pull slightly. So I believe it swings. It swings to the north if you're accelerating and south if you're decelerating.
Awesome. That was a lot of detail on the compass. I love that.
A few different times where that's all I've had to rely on. The only instrument failure I've had was at night when my heading indicator stopped working. Like I couldn't reset it anymore.
Oh dear. Oh God. Yeah, that's not a fun experience, right? So
I was supposed to be going to a new airport actually, and it was one of those things where I was like thinking through like everything they've taught, and I was like, is it necessary to go to the new airport? Not really. Do I need to prove anything? No. Like, could I probably do it in an emergency? Yeah, but I could just go back to my home airport right now.
Yep. I love it. Amazing decision making. Never end up in that get there-itis. I am one to admit that I've gotten into situations that I shouldn't have in an airplane trying to impress a girl.
The downfall of many men, I'm sure.
I don't recommend icing conditions in a Cessna. But let's talk about turn indicators. You initially brought up a turn coordinator. What's the other type of turn indicator?
I believe it's turn and slip is the other one. Now, my school has turn coordinators. So I know what a turn and slip is, but I actually haven't used it in person.
Yeah, most people haven't because they suck. But what's the difference?
One, I believe, shows rate of turn, or both show rates of turn. One shows yaw is no, I guess the slip would show yaw either way. One shows maybe bank as well.
So it's not necessarily bank; it's rate of roll.
Rate of roll.
Rate of roll, right? Which one shows rate of roll?
I believe that turn coordinator shows the rate of roll as well.
Turn coordinator. That one's the much nicer one. Why does it show rate of roll, but the turn and slip indicator can't? What's different?
I would not be sure on the differences. I would assume it's the way that the gyroscope is set up behind the actual panel.
Yeah. So what instrument or what gyroscopic principle does the turn indicator function on?
That one is going to be precession. So it's slanted so that then it can act at a 90-degree angle relative to roll in order to show, I guess it'll be moving forwards and back and then indicate on your instrument.
Right.
Yeah.
And that's the thing. You just brought up the difference. It's canted.
Okay, so the turn and slip is not.
Yeah. That's the whole difference, right? Because if we had a gyro just spinning like this and the gimbal was just down here at the bottom, the only thing it would ever tell me is yaw, right? But the fact that I've tilted that gimbal at a 45, it can now tell me yaw and roll.
Oh, okay.
Right.
That makes sense.
So you knew the difference. It's just you had never looked at the other one to know that there was even a difference.
Right. Okay.
Right.
Cool.
Awesome. Now let's get into some pitot-static instruments. How does your altimeter work?
The altimeter is basically an aneroid wafer that then is measuring the difference in, let's say, ambient pressure. So I have a set pressure within the aneroid wafers, and then my static port is taking in the ambient pressure from whatever altitude I'm at, and it is expanding and contracting to then reflect what altitude I'm at. Depending on, I have the Coulson window as well in ours, so I can adjust it for local pressure settings.
Awesome, right? The way I explain it is the aneroid wafer, it's a balloon.
Mm-hmm. Right. Okay.
Or a bag of Lay's potato chips. Everybody in an airplane, everybody has been on an airplane. Like most people have taken a flight nowadays. And if you've been on Delta, you have gotten a bag of Sun Chips.
Yeah.
Okay. Aneroid wafer, it's a bag of Sun Chips on Delta. When I'm up at altitude, that bag is all right. And it's via mechanical linkage. That expansion is then being, shown on the dial. So amazing explanation. We can dumb it down a little bit.
Okay.
I love the high dollar words. But the way that at least I've seen to check a lot of knowledge on whether or not it's a rote level of knowledge or there's like an understanding, we go through different layers of understanding, is if someone can, for lack of a better term, break it down Barney style.
Okay.
Could you put this on Barney and Friends and the kids would get it?
Right.
And, hey, it's a big balloon. It's a bag of Sun Chips. Everybody gets that reference.
Yeah.
Go ahead.
I had an interesting experience with my private check ride where I think I explained a lot of things in layman's terms, and the DP got a little frustrated with me at one point. He said, "You're speaking like a civilian, and I need you to speak like a pilot." There are a few buzzwords I didn't hit, and yeah, I was a little bit not taken aback, but it kind of hit my confidence for the rest of the check ride, where I was like, "Do you think I don't know what I'm talking about?"
Yeah.
Which, by comparison, I didn't know as much then, but still.
Yeah, and I mean that's odd because like DP's probably been doing this longer than me. So if that's what your DPE wants is the buzzwords, the aneroid barometer, because I've got a whole bunch of buzzwords highlighted: aneroid barometer, mechanical linkage, altimeter setting knob. You memorizing those highlighted phrases doesn't tell me anything.
Right. It doesn't always show that you know how it works.
Yep.
You can memorize a definition and be oblivious to. Yeah, I think thankfully I have a different DPE this time. So
that's good. What's one of our big errors that might apply to an altimeter?
I would say a big error would be if your static port becomes blocked.
Well, not necessarily malfunctions, but an error that could ensue if I'm just too lazy to adjust my altimeter.
Yeah. So anytime that you're below, let's say Class A airspace, that flight level 180, if you didn't adjust it, now everybody's not on the same page. Basically, when you're setting your altimeter, and ATC is telling you to be at a certain flight level for traffic avoidance or obstacle avoidance, whatever it is, you might not be at the same level as them. Or, just for your own safety, you move from a high pressure to a low pressure area, or from a hot area to a cold area. Okay. Now you're going to be lower than indicated.
Awesome. That's what I was getting at, is that high to low, watch out below, hot to cold. I don't know the mnemonic for hot to cold.
I don't know either.
Right. But what are the different kinds of altitude that would that's really important in aviation?
Different types of altitude. Yeah. MSL is going to be our height above sea level. It's your actual height. We also have AGL, so that's just above ground level. We have our pressure altitude as well, which is right above the standard datum plane. That's going to be used anytime that you're basically in Class A airspace. Those are the big ones that are really important. You got density altitude as well, which is really helpful for knowing the plane and takeoff and landing performance, how the plane is going to act like it's at.
All right. Last one, uncorrected, or not uncorrected, indicated, which is uncorrected indicated altitude. Yeah. Which we already talked about. We got two more Pitot-static instruments. Talk to me about the vertical speed indicator.
Sure. Vertical speed indicator is also operating off of your static port mainly. The rate is going to be instantaneous, whether it's positive or negative, but usually I'm blanking on the word for whether or not it's positive or negative, is going to be instantaneous, but the actual feet per minute is going to have a 6 to 9 second lag. So it's good as a performance instrument, but it's usually secondary to your actual control instruments.
All right. Now, how does that work? I'm looking for those buzzwords. What's
Yeah. Vertical speed indicator is going to have a I want to say that there's a small drain hole, and that is then measuring the rate of change that the aneroid wafer is expanding or contracting. No, that wouldn't be for the altimeter. Yeah, that would be the changes in. I guess I got a little.
So vertical
turnaround.
Speed, we'll break it down a little bit, right? So vertical speed indicator, the way that it's measuring it is it's measuring a rate of change. Okay.
Right.
So the case has a calibrated leak in it or a restricted orifice, right? So the case has static pressure coming into it, and it leaks out via a calibrated orifice. Okay. So the case is holding on to what the pressure was a little while ago, but into the actual wafer or the diaphragm is actual raw static pressure.
Instantaneous.
So since it's measuring based on that calibrated leak what it was a little while ago, versus what's in the diaphragm, that's where you get the deflection.
Right. Okay.
Right?
That makes sense.
That buzzword they're really going to be looking for is that calibrated leak.
Calibrated leak.
Yep. So
I was about to say that, and then for a second I got it conflicted with the drain hole for the ram air, and I was like, wait, am I about to explain the wrong thing?
yep.
But yeah, calibrated leak for VSI.
Right. And sure, VSIs, they do have that 6 to 9 second lag. There are technically instantaneous VSIs that have some accelerometers in them that try to get rid of that. So just be aware that you might have a fancier VSI in a nicer airplane one day. All right. Last pitot-static instrument, airspeed indicator.
Yeah, so airspeed indicator then is basically measuring the ram air pressure. So that is obviously subject to blockage if you now don't have any air intake. There is a drain hole in the back as well, so that can become blocked too.
Okay, so what would happen to my airspeed if my static port got plugged and I continued to climb?
So yeah, if your static port becomes blocked, then it's going to be measuring ram air, but now there is a seal on that initial ambient air pressure. So the outside air is now not in that measuring device, is not going to be moving. And so as you climb in altitude, it's going to be acting as a reverse altimeter, because you're going to have an expansion of what would have been the static port input. And so the ram air pressure will be showing that it's lowering, versus then when you descend, the opposite happens, where what would have been in the static port heightens in pressure and condenses and now shows a high airspeed. So reverse altimeter, basically.
Yeah, I mean that's not bad. I mean, I'm a little iffy on the reverse altimeter because I mean it's still giving you some airspeed data. It's not giving you altitude data.
Okay.
That's just my one kind of like on that.
Okay, yeah, because it won't be like a 1-for-1, but it at least shows reverse.
Yeah, what you're going to notice is that the airspeed is going to be decreasing at a greater rate than what you'd be expecting as you climb, right? So we all know, like, hey, in our piston-powered airplanes, like we lose performance as we climb, right? It's
right.
Just going to happen. But what you're going to notice is that you're going to be at full power at like 1 degree nose up, going, why am I doing 80 knots and 10 feet per minute?
Mm-hmm.
Right. I've done it to students in the Airbus in the full motion sim. I've plugged up all their static ports. And since it's been so long since they did instrument training, they're lost in the sauce. And they're like, why am I doing 80 knots at 32,000 feet?
It's not registering.
It's not there. So just because you're in the airlines doesn't mean that you can throw this stuff out. Right, viewers? Now, what are our different kinds of airspeed that we could see?
We have indicated airspeed, which is going to be that raw data from what we're seeing on the airspeed indicator. We could have calibrated airspeed as well. So that's going to be in your POH, and it's going to give you a few corrections for the instrument itself. There is an equivalent airspeed, which is due to like compressibility error. That's not really applicable to my aircraft because I'm not going to reach those speeds. You could have true airspeed as well, which I believe is just what's corrected for non-standard temperature and pressure. And then you could have ground speed, which is corrected for wind correction angles.
You forgot Mach number. No, I'm kidding. We're doing 0.02 Mach. Awesome. Right. Now, let's talk about the equipment that you need to go fly around in IFR. Now,
sure.
We all remember VFR day, VFR night. I'm going to assume you got that. Let's talk about specifically IFR.
Specifically for IFR, so we're going to need everything that's required for VFR day and night across the board. And then for IFR, we are going to need a generator or alternator of some kind. We're going to need radios and suitable navigation for the route that's going to be flown. We need a sensitive altimeter, so that means one that has the adjustable Colesman's window. I need a ball which is going to show my slips and skids. I need a clock that has to be either, it has to be panel mounted. It can't just be like a wristwatch or on my iPhone. It has to be part of the airplane itself. And that has to have a second-hand sweeper or the second's digitally represented. I also have to have an artificial horizon, so my attitude indicator, for lack of a better word. And then I need to have a rate of turn indicator and a directional indicator, which is gyroscopic. The last one I heard that some DPs are looking for is making sure that you have DME when you're above flight level 240, which not applicable to me yet, but eventually.
Yeah, hopefully, eventually, right? DME or RNAV is also an option, right? So VOR, DME, or RNAV. And since you brought that up, let's talk about it. What is RNAV?
Yeah, RNAV is it's area navigation. So the way that I understand it is instead of having to fly specifically from point to point, we have a series of satellites. There's a global satellite system. At least 24 satellites that are always in orbit. We have to have a certain number of satellites for each level of accuracy. So if we want two-dimensional reporting, then we need 3 satellites to tell us that. If we want our altitude as well, then we're going to need 4 satellites. If we want to have RAIM, which is fault detection, basically we need 5 satellites within view, or we need 4 plus like a baro aiding system. If we want fault exclusion, so RAIM being able to detect and get rid of the corrupted signal, then we need 6 satellites or 5 with the baro aiding. And all those satellites are going to be using triangulation to then just take us straight to GPS fixes, or, not necessarily from VOR station to VOR station, but directly wherever we want to go.
All right. Is that all RNAV is? So everyone thinks RNAV and GPS are the exact same thing.
Okay.
RNAV and GPS is not the exact same thing. GPS can be used in lieu of all other, requirements of RNAV, but RNAV isn't solely reliant on GPS, is really what I'm getting at. And the aircraft that I bring up is the CRJ-200. I know it's an old airplane. It's a jet beyond what you're currently operating in. I get that. But the first thing that the CRJ-200 looks for is 6 DMEs in its RNAV.
Interesting. Okay.
If it can't find 6 DMEs, it looks for VORs, and it'll go to all the way to 3 different VORs and then as many DMEs as it can get. And then it uses GPS as almost like a correction.
Interesting. Okay, so it's pretty much any, like you're using multiple inputs to then triangulate location for navigation.
Yep, it's really any nav source that's available within the service volume of that one nav source, GPS, but it also includes inertial reference units, which is not an external system.
Okay.
And do you know what an inertial reference unit is?
No, if you could elaborate.
So an inertial reference unit, what it does is it's the airplane has a box in it that goes, okay, I accelerated at 1G for 30 seconds and then stopped accelerating and maintained that rate for 5 minutes. So I must be here now.
Okay.
All right. It didn't listen to anything outside. It said, okay, I got jerked around this much, so I must be here. That's how we used to get to Hawaii in the 70s.
That's terrifying.
Yes, it's very terrifying. But it falls under RNAV. Okay. So those RNAV only approaches that you've seen, those can be done with an IRU.
Wow.
Right?
Okay.
Sure. In the modern era, it's going to be GPS. But when you get to the airlines, especially if you got to get banged around at a freaking regional for a little while, you're going to be using actual RNAV. Because RNAV was developed before GPS was.
Okay. Interesting.
Okay. GPS fell under RNAV's classification. Okay. RNAV was used back before GPS was really readily available to aircraft. And that's a lot of how we used to get around in the contiguous United States. And then we'd use IRUs to get across oceans.
Okay. So then if you go to define RNAV without just saying that it's GPS, you would say it's any,
I would say that RNAV includes GPS, VOR, DME, RNAV, DME, DME, RNAV, IRUs, or IRSs.
Okay. And that'd be a good.
That would be a pretty good definition of RNAV. I asked what RNAV was, and you said you gave me a really good description of GPS, right? Which is great. You explained GPS perfectly. I have no questions on GPS. Right?
But RNAV is a bigger scope than that.
Yes. If we're talking about like an envelope or like an umbrella, like RNAV is an umbrella that sits over kind of all conjoining nav aids.
Okay.
Right.
Perfect.
Because, in your instrument training, you've probably been told like track out on this radial to intercept this VOR, to intercept this radial and track inbound on that for a 5 DME arc to go around that. That is pre-RNAV navigation. That is conventional IFR navigation. What RNAV is doing is it's building routes and structures based on those style of clearances. It's just a whole lot easier.
Right.
Do the RNAV procedure as opposed to track outbound on the Stanfield VOR radial 040 until you intercept from the Tucson radial VOR 270, what have you, to track inbound to a 5 DME to intercept the localizer to track inbound to Tucson. Instead, do the Tucson arrival for the ILS runway 1 into Tucson. Much easier clearance. All right. Now, have you flown on VORs? If you, I know a lot of students are really like VORs aren't really around that much. So have you actually used VORs?
We use it a decent amount here. And I think the instructors are pretty big on making sure that you can fly it and understand it. Unfortunately, right now, I think 2 out of the 3 nearby are out. So I don't know how much I'll use it on the check ride next week. I tried to use it a decent amount on, we have Pahokee, which is then going to give an RNAV approach. But I'll usually intercept one of the radios the initial fix is on, track it inbound to the initial fix, and then start the RNAV approach. And then sometimes I triangulate. I use 2 VORs to, after we've done maneuvers, tell my instructor where I am, do things like that.
That is absolutely awesome. You're lucky that you've got 3, and even if 2 of them are broken, I had 1 and it broke. So I'm sitting here like, and it's kind of concerning because it's technically supposed to be part of the minimum operational network.
Right, because GPS is not the standard in the U.S. since, it could go out or military reasons or whatever. So at any point, we could just all rely back on VOR.
Yep. But what I was really getting at is, can you tell me the difference between the CDI display of a GPS versus a VOR?
My understanding is, so in my plane, I have the KLN 93. Not necessarily the newest technology, but my understanding is that the VOR shows your angular displacement, whereas the GPS shows distance displacement.
All right,
so just straight horizontal.
KLN 90. Oh yeah. I've got that. See, I've got something similar to that. Yeah, it's not great. That GPS
definitely clunky.
But that is correct, right? The GPS is showing you lateral distance off course. The VOR is showing you angular in degrees off course.
Mm-hmm.
Awesome. We talked about RAIM. What other systems in GPS would make it even more accurate?
We have, I don't have WAAS, but some of our planes have WAAS as well. And that is going to be like a satellite-based augmentation system, I believe. I know there's a master station. I'm hesitant now to say whether it's satellite-based or land-based. I know there's GBAS as well, GBAS, and that would be ground based. So I want to say WAAS is satellite based, and that would be a master station then collecting all of the information and basically giving you a more accurate and like fine tuning out any errors, so that for that area you have more accurate information for your specific position and altitude. You can also, like I said, have land-based systems as well. So I believe that would be like a GLS. That one I never seen around here or heard about as much in person. I've just kind of read that it would be like an even smaller network or an even smaller area than WAAS.
All right. So this is a diagram for WAAS. Okay. So this is how WAAS works. You were right initially. There is ground reference stations. Okay.
Mm-hmm.
There is also a geostationary satellite. You know what I mean by geostationary?
That's one that actually stays in the same spot above the surface of the Earth.
Awesome. Right. So you've got a geostationary satellite. So this satellite's like, I am always here. I am not moving. Then you have ground stations, which, like, you know, foregoing a earthquake, they're not moving, right? Last time I checked, mountains don't move, you know, foregoing an earthquake. So these ground stations are also talking to the normal GPS satellites, providing them corrections. Then you've also got another GPS rover that's receiving more stuff. So there's a ground portion to it, a geostationary satellite portion, and then you also have your normal GPS satellites. Okay. And given that you don't spend, given the GPS that you use, you don't spend a whole lot of time using it. So I can't really blame you for having a little bit of a struggle on that one. Now, what can WAAS allow me to do, though?
Yeah, so WAAS can enable you to have precision-like approaches with RNAV, or with GPS specifically. So instead of, like, for example, right now with my KLN 93, I go from like 2 miles of deviation in the on-ramp phase to once I'm 30 miles away, it goes to 1 nautical mile. And then 2 miles before the final approach base, it goes to 0.3. Instead, with WAAS, you can have like localizer-like performance where it's actually angled in and becomes more sensitive the closer that you get. So WAAS will enable that, which then gives you usually slightly lower decision heights or decision altitudes.
Awesome. Only other thing it gives you, vertical guidance.
Yes. Yeah, vertical guidance is fine.
Vertical guidance. So you had it perfect with the localizer performance style approaches. You can get localizer performance style approaches with vertical guidance as well. Okay.
Would those just be advisory only when it's with WAAS? Or you can actually follow the glide slope?
You can follow it. Send it.
Okay.
Right. That's how the Airbus lands in many cases, is with an LPV. And it still technically can't do an auto land on it. You need a GBAS to do that. But GBAS has only been certified for Category 1 right now, and you'll learn about all that in your type rating. A little bit more down the line.
Yeah, I was about to say, a little ways away.
If I'm still teaching in the 320, maybe I'll teach you.
Okay, cool. Yep.
All right, GBAS, it's ground-based augmentation system. My wife, she's an airline pilot. She flies for a major airline. She knows of one of these in California.
Wow.
So it exists. It's really just fancier LPV. Okay.
Fairly rare, right?
Yeah, I only know of one. She only knows of one. All right, but it was formerly known as LOS, local area augmentation system. So we had WAAS, wide area augmentation system. Then we had LOS, local area augmentation system, which got changed to GBAS, ground based augmentation system. In case again you get an older DPE that still thinks it's LOS.
And that's just more sensitive but a smaller area.
Well, it's more
essentially.
sensitive in a smaller area. And, in my little notes, let me read through it. Errors are broadcast via VHF to a GBAS-enabled GPS receiver. GBAS is more accurate than WAAS, but covers a much smaller geographic location. So really what it's doing is saying, hey, I've got a ground-based radio aid that's giving corrections to your GPS.
Okay.
Why we don't just put an ILS there? I don't know. Like if we already had to put something on the ground,
Right.
but I'm not the FAA. I don't design the aerospace system. Now let's get into some required reporting. While you're out on a cross country, minding your own business, doing your thing, what are you required to report to ATC under IFR control?
There's a number of things. Anytime that I go missed, I need to report that. Anytime I have an airspeed change of greater than 5% of what I filed, or plus or minus, I believe it's actually greater than 5% of what I filed, or 10 knots of airspeed. I might have been mixing that up. I can double check in the arm in 2 seconds.
You're good. That's
okay. Anytime that you have that you vacate an altitude while you're on VFR on top. When we have an ETA change of plus or minus 2 minutes, that one will also be that one is just required in non-radar environments. If we have if we leave a holding fix, any hold, if we leave that, anytime that we reach an outer marker or a fix that's used in lieu of it, that one also is only in non-radar environments. And unforecast weather, anything that's pertinent to the safety of the flight, we have to report. And then vacating a flight level or an altitude, any final approach fix, that one is just in non-radar environments. And then the failure of any radios or navigation equipment needs to be reported. If we are unable to climb or descend at 500 feet per minute, then we need to report that as well.
All right. What? I might have missed it. Did you get
compulsory?
There it is. There it is. How are those depicted on a chart?
Those will be instead of like a hollow fix, it'll be blacked out. Could be, like a triangular fix. It could be a VORTAC or VOR. It'll be a black symbol though.
All right. Filled in symbol. Awesome. Now let's say you're out cruising along, minding your own business, and your radio dies. Oh, shucks. What are you going to
do? Before I do anything, I'm going to make sure that it's not just an error on my end. Like, my headset didn't become unplugged or that I hit like the speaker button or something like that. I might even toggle between COM 1 and COM 2, seeing if both radios are out or if it's just one. I might hop back to the previous frequency just before I start, walking and, going through emergency procedures. Just want to double check my bases and verify that. If I've already done all that and it seems like my radios are actually down, then I'm going to switch my transponder to 7600 for that lost comm squawk. And there's a number of things I'm going to do. One, in terms of altitude, I'm going to be at either the minimum IFR altitude for the segment that I'm on, or the expected altitude, or the assigned.
Okay.
And then in terms, and that would just be in whichever is the hottest of those three. And then in terms of the route that I'm on, I would either be going along what has been directly assigned by ATC. Sorry, I think that's just the iPhone update that's giving the thumbs up on my screen.
You're good.
It would be either the assigned, vectored, expected, or filed in that order. So, you don't have the assigned, then go to what was vectored. If you don't have what was vectored, go to what was expected, like in your clearance. If you don't have what was expected, then go to what at least was filed. And that would be kind of your priority list.
All right. Now, let's say your radio died, you continued on your route, you hit your clearance limit.
Mm-hmm.
What next?
Right. So if my clearance limit is a fix from which an approach begins, then I would start that approach at the time that would most closely get me to the airport at my expected arrival time. If my clearance limit was just the airport, then I'm going to, let's say, hold at like an outer marker or a fix in order to just try and time and get to my destination at the expected arrival time.
Okay. Yep. Got it. Yeah, I was just double checking, reading through my notes, making sure I didn't miss anything. Awesome.
Mm-hmm.
I love it. Now, let's say we're doing that approach, right? We got our radios back. No longer are we terrified because our radios are dead. When can I descend below MDA or DA?
So I'm assuming I'm on an approach at this point.
Yeah, you're on an approach at this point, right?
Yeah, I can only descend below the MDA or the DA when I have certain visual confirmation. So one of those being like the approach lighting system. And even then, I can only go within 100 feet of AGL when I have like the red terminating sidebars or the red terminating bars or the red sidebars in view. Besides that, I need to have the runway, its markings, its lights clearly identifiable and in sight, and I need to be able to descend with normal maneuvers to the runway. It could be the threshold, its markings or its lightings. It could be the touchdown zone or its markings or its lightings. It could be the runway end identifier lights, or it could be the VASI, the visual aid as well, like glide slope lights. Awesome. So one of the things has to be visible and clearly identifiable before I can descend below that DA.
Below 100 feet above touchdown, the pilot may not descend below 100 feet above touchdown zone elevation using the approach lights as reference unless the, yep, got that right. All right. That one always trips me up a little bit because it's worded so weirdly. The red terminating bars one.
I probably didn't word it great either.
No, you are good. It is awesome that's perfect. This one's going to make for really boring content because it's going to be like, here's the question. You are going to respond perfectly. You got to miss one or two of them. No.
Yeah. Well, the problem is I had, like I told you, I finished my instrument training with my school a month ago.
Yeah.
And so now I've had about 4 months to just incubate with the study guides.
Yeah. I can definitely see that. Right. I'm trying to dig into some icing conditions. What are the two conditions that are required for structural icing?
So for structural icing, we're going to need visible moisture. And then we also need to be near or below the freezing level.
Right. Or aircraft surface temperatures below freezing.
Right.
Because if I've got a heated airplane, it's not going to happen, right? What are some anti-ice systems? I know you're just in like a Cessna 172, correct?
Right. Yeah. I'm flying into known icing conditions in my POH.
Awesome. But what anti-ice do you have?
I do have pitot heat, which is both anti-ice and de-icing, technically. And then I do have some windshield defrost, although I've never had to use it in South Florida, of course. I believe those are the only two that I have with my 172.
Yeah, that's the only two that I can think of. Awesome. Let's talk about some spatial disorientation, right? What causes a graveyard spiral?
Graveyard spiral, from my understanding, is when you have entered a bank for long enough that your vestibular system then resets. And if you go to bank out of it, you now have the illusion of banking the opposite direction. So you continue into the bank and then effectively just tighten your turn and then most likely lose altitude. Or if you're over banking, then you might start to like pitch up a little bit, which then just tightens the spin. I might be conflating the two. I think there's graveyard spin and graveyard spiral. Are they two different things technically?
Yeah, I mean a graveyard spin. I mean that's a spin. So let's just so that we can kind of drill down exactly what the difference is between a spin and a spiral. Well, I'm going to ask, what's the difference between a spin and a spiral?
Yeah, I just thought of that. Yeah, actually. So the spin would be if you actually enter. Would that be if you actually enter a spin with installing one of the wings, and then your vestibular system resets during that spin? Versus a spiral would just be an overbanking.
No, I mean when I'm saying difference between a spiral and a spiral, the axis of rotation is outside of the airplane. The spin, the axis of rotation is inside the airplane, right? So spiral, right? Spin.
There's a spin.
Yep. When it comes to graveyards, the graveyard portion of it is really just the fact that you're gonna die. I know that's a terrible way to put it, and you're not recognizing what got you there.
Right.
You're not recognizing that you do have disorientation, that you are disoriented. Because let's be honest, if you get into a spin in IFR, like if you didn't recognize that you got into that situation, you could just think that your heading indicator's busted.
Oh, that's terrifying. Yeah.
Right. But of course, there's other environmental factors at play that might, convince you that you're in a spin. But if you're convinced that you should have never been near that because you had lost your situational awareness because you'd gotten the leans, Coriolis illusions, all kinds of other jazz. All right. I would really just focus on the graveyard spiral. The graveyard spiral is the one that you're most likely going to end up in because you've really got to stall before you can enter a spin.
Right.
Now, let's talk about some visual illusions. Okay. In IFR, if you are IFR on top or VFR on top is the right way to say it. If you're VFR on top, what are some of the illusions that I could fall victim to up there?
Visual illusions or optical illusions in VFR on top.
Mm-hmm.
I guess there could be false horizons. So you could have horizon obscuration due to clouds or sea. And you could have, like, let's say you're out over the ocean, either boat lights that then make you think the horizon is a different spot, or maybe satellites or stars that you mistake for horizon reference points.
Yeah, that's it.
Okay. I was like trying to rack my brain if there was anything else.
No, I mean, it's just, false horizon illusion, which the pilot has misidentified the horizon line. It may be caused by sloping cloud formations, obscured horizon, aurora borealis, dark night with scattered lights and stars, or the geometry of the ground. Right? Now, did you get taught control performance or primary supporting when it came to control and under IFR conditions?
None of that specifically rings a bell. Control.
I know, just gonna be honest, I didn't like teaching control performance. You know why? Or not control performance. I didn't like teaching primary supporting because it required me to actually memorize stuff. But primary supporting, I'll open up a chart. Primary supporting instruments, images. I like this one. Let's go there. It's just a knockoff of bold method. Either way. Let's go. No, wrong page. There it is. Have you ever seen a chart like this?
No, definitely not.
Okay. So 2 different ways to control an aircraft under IFR conditions, right? You've got control performance, which is I'm going to set a pitch and I'm going to set a power and the airplane's going to fly. Right?
Right.
What happens if your attitude indicator dies?
Well, you know the performance specifications you need for like a climb, for constant
But
buffers.
here's the thing. If you don't know anything beyond what your pitch attitude should be based on what, right? And that's why I like to teach primary supporting and I teach control performance as backup, because that's what the airlines do. Airlines teach control performance. Correction. They teach primary supporting and they have a chart to be used as backup in the event that you lose some kind of instrumentation, that you lose airspeed data, so that you can set a pitch setting, set a power setting, and the airplane will fly. Right?
Interesting.
And it's great if you never fly anything else. But here's the thing. Your IFR rating is not an IFR rating for a Cessna 172 at your flight school.
Right.
Your IFR rating is good for anything. And primary supporting is good for anything. Okay. So when I look at this one, can you see this? I see straight and level flight right here, right? My primary power instrument is my airspeed indicator, which seems a little weird given all of the experience of not using your airspeed indicator as a power instrument.
Right.
And then your altimeter is your primary pitch, because it's going to be the first thing to respond if your pitch is wrong. Does that make sense?
It does make sense.
And then my supporting pitch is my vertical speed indicator, because it takes a little while to catch up. But as you can see, my tachometer is way over here as a supporting power instrument. The reason it is because in any airplane, wider than a Volkswagen Beetle, the tachometer is like over there.
Right.
It's not in front of you like it is in a Cessna. Now, I'm not saying that you need to go memorize this chart. All right. I know you got your check ride coming up soon, so don't look at it, read it, take it into account in your further experiences in IFR.
Okay. Yeah.
Because as you can see right over here, your attitude indicator, which is a dual gimbal gyro that just has so many moving parts, it's going to be the one that's most likely to fail.
Right.
Right.
That makes sense.
I can, under the primary supporting flying method, a lot of this can really be flown without your attitude indicator. Your attitude indicator is really only a primary pitch indication for starting turns or starting climbs and descents. So you're never relying on your attitude indicator. And I know you're sitting here going, how the hell am I ever going to remember this chart?
It's hefty for sure.
Where can I get the information other than the attitude indicator? That's
For pitch and bank?
for anything, right? Where else can I get this information? So straight and level flight, right? If I'm banking, my turn coordinator is probably going to tell me. My heading indicator is going to tell me. So I have all these other things that are telling me if my bank is correct.
Right.
All right. Because my attitude indicator in my airplane falls over like every 20 minutes. I don't fly at IFR, but when I'm crossing because it's a seaplane, so when I'm crossing the water, if it's a little foggy down there near the water, or a little misty down there near the water, I need to make sure, like, hey, am I good? Right. So just take this chart into account. I really love it because it can apply to any airplane.
Mm-hmm.
Your current airplane, like a cruise in a Cessna, is like 2,400 RPM and like 1 degree pitch up.
Right.
Try that in a Bonanza. You're going to be climbing. Right. So don't rack your brain over it. Don't be nervous about your check ride about it. Just recognize that there is another method that will transfer to literally any airplane you get yourself in.
Right.
All right. That's the only.
I've probably thought about this a little bit more than I realized because of how much partial panel they've had me do, where I noticed a tendency that now in the simulator and a little bit in flight, I actually have to tell myself to use the attitude indicator because there's so much time that I've spent in partial panel not trusting it or not looking at it. I've been looking at the performance indicators instead.
Exactly, and that's kind of why I really like it, is because this is perfect for partial panel.
Mm-hmm.
Because if they put that stupid sticky note over your attitude indicator and you're like, son of a...
Right.
Or I'm assuming they actually have like the real cards that actually fit in there. They're not over there using sticky notes. I use sticky notes.
Only one of my instructors had the actual, it was like a cup holder almost, that like suctioned onto it. The rest has been sticky notes. I
absolutely love sticky notes. When I was teaching at a G1000, there's like a whole card that you like shove onto the knobs. But yeah, just realize it's a thing. Learn it, but don't be nervous about it on your check ride. Okay.
Yeah.
So I was, as you were going through some of this stuff, I was trying to build you your route. Let me go back over to your, where'd it go? Oh, there it is. All right. So it looks like T347. Now, my only concern with T347 isn't that a GPS route? Oh, you have a GPS. I'm stupid.
No, yeah, it's okay. It is a GPS route, though.
Yep. That's why I was over here trying to do a VOR route. I was like, for some reason, I thought he only had VORs. Let's dig into a couple of things on this chart on the way down there. What are these little blue lines adjacent to this diamond fix or this triangle fix?
I think it might still be. I'm on the.
IFR wrong screen.
I can grab my low end route as well.
Why is it still showing that thing? Let's go to Sky Vector over here. Sure. All right, there it is. Oh, but that's not the right airport. What was the airports again?
Kilo Papa Mike Papa to Kilo India Sierra Mike.
Oh, no, that is it. Oh, awesome. All right. Now you can see it, right?
Correct.
Awesome. So these little blue lines, what are those?
Those like bookends on the airways, I believe, are when there's an altitude difference in the MEA between the two different segments.
All right. So when do I need to start my climb or descent, if necessary?
I want to say it's in order to. So if there's a minimum crossing altitude, then you would need to start in order to be at that altitude by the time you cross the fix. If not, then I believe that it's just once you cross the fix, or within, it might be like 2 minutes of arrival at it. I think I read that right.
Yeah, I'm trying to find it on my little study guide just to make sure that I'm not wrong, because that's the last thing I want to do is right before your check ride give you wrong information.
No, you're right.
Where did all my little flags go? That's a compulsory waiting. That's the VOR changeover. Okay. You know what? I'm going to have to find that elsewhere. But I do believe, yes, you are correct. That's a minimum crossing altitude. For you to clear that, you do need to make sure that you can cross it. This one, you can start your climb at the fix. I forget if you can start beforehand. I bet if I come over here and I go in route and I go over to the, I forgot they don't put the key on the dang IFR ones. All right, continuing on. What is this right here? The little 30 with the arrow and the little curved side to it.
Yeah. So I know there's a difference between whether it's hollow or black. And I believe if it's hollow, like that one, then that would be the distance from which that fix is identifiable from a VOR. So that'd be 30 nautical miles.
Awesome. Continuing on. What's this?
The gray racetrack.
Yep.
That is going to be a hold. I don't know if there's a specification on whether or not that's published or if that's like depicted anywhere else, but looks like
Yeah.
yeah.
What else? I know the IFR sectionals seem so complicated, but like then when you read them, you're like, there's not a whole lot going on here, right? What's this? What's the 2600 right here?
2600. That's going to be my minimum en route altitude for that Victor Airway. So that guarantees obstacle obstruction as well as adequate coverage at that altitude.
All right. Now what's this one?
Yeah, that one is more going on. So the adequate coverage for anything besides GPS is only at 6,000. You can still get adequate coverage for GPS at 2,000. And then just for obstacle is going to be, it looks like 2,000 as well. I don't know, there's a little line going through it.
Oh.
Oh, yeah, okay. So 2,000 as well for just obstacle.
All right. Now, what is this?
That is my Oroka. So anytime I'm off my route, the obstruction clearance is going to be 1,700 feet for that area. So since Florida is non-mountainous, that gives 1,000 feet of obstacle clearance above the highest obstacle in that area, that quadrant.
Awesome. What's this one?
Oh, that is an airway that's no longer in use.
Awesome.
It's closed.
Road's closed, man. You can't park here. All right. Is there anything on here that you're like a little iffy on or that you're concerned about?
Honestly, like you said, the IFR one is pretty straightforward.
All right. Let me just
Go
ahead.
I was going to say green, blue, and brown airports.
Ooh.
Browns don't have like published instrument approaches. Obviously, not every airport is going to be even depicted on the IFR low end route.
Mm-hmm.
And green and blue, I think.
Isn't that the controlled versus uncontrolled?
I think it's like, I know it's in the key, but I basically mess up explaining it each time. It's phrased interestingly. Blue have an instrument approach and or a radar minima published in at least the high altitude DOD flips.
Okay.
But green have one or the other, I believe.
I'm digging through.
I don't know how crucial that is for.
To be honest, I'm a little on that one. I'm gonna have to look that one up if I'm gonna be frank about it. I am definitely gonna have to look that one up. Stand by.
I think the only other thing that I'm a little iffy on is for flight planning. I know that the IFR en route, the low en route chart is through, but obviously has a lot of magnetic routes on it, like anything from a VOR. But then, of course, if you use like an EFB, it's going to give you magnetic.
Yeah, the EFB is going to give you what you should be aiming for. The only problem is it's not. Yeah, it's going to be magnetic because they're under the impression that you are going to have a heading indicator. right?
Mhm.
Not a magnetometer. Other way around, that you're going to have like a magnetometer versus a heading indicator that you've got to compensate with deviation.
Right. Okay. So even though the chart is true, you want to be aiming for magnetic, and there are a lot of magnetic routes on the low end route.
Yes, but I mean, I think what's more important is knowing the magnetic heading to aim for, so that you can grab your course if you're crossing over a VOR. But here's the thing: if you're using GPS, I mean, you're using GPS.
Right.
You know, they don't call it "I follow roads" for nothing.
True.
I am struggling to find that because I'm on the IFR low in route for US and Alaska, and I'm looking at this, and I am not seeing. Like, I'm just seeing that they are different colors,
Mhm.
but I am not seeing specifically why.
Right.
And it's kind of
Yeah, I know.
embarrassing.
No, it's okay. On the printed one, it's got a little WAAS up top. So I don't know if that would be on any other resources. But like I said, it's phrased a little interestingly. I don't know if you can read that or if it's reversed because I'm using my front camera.
Oh, let me see. Yeah, see, and that's what I found. But okay, you've got it right up there. I think I just found it on. To be honest, I just asked ChatGPT.
Nice.
Blue airports. Blue airports have an approved instrument approach procedure and or radar minimum published. These procedures can be found on the FAA charts, like you said. Right. Green airports also have an approved instrument approach procedure and or radar minima. However, these procedures are not found in the FAA terminal procedure publication and are not necessarily in the DoD high altitude flips.
Okay.
So
So basically the blue ones might have military activity going on. Sounds like.
Yes, I see that. Yes, it seems like blue says that the military can do approaches in there. Green is saying that there's not necessarily a published approach for DoD.
Right.
It doesn't say that there isn't. It just says that it doesn't guarantee it.
Okay.
And that is a really weird. I don't know.
It seems like an important distinction since it's like literally the first thing on the legend, but
yeah, that is definitely an interesting one. Now, this one's a pretty complicated approach plate.
Mhm.
It's just a busy airport, right? So, can you give me an approach briefing off of this?
Sure. Sorry, I'm using my phone. So
No, you're good. Do you need to look it up? It's the ILS runway 18 into Charlotte, CLT.
Let's see. I'll look it up really quick. ILS 18
Center.
feet. Yeah, so if I was going to give a briefing, first I would brief any NOTAMs. So like right now, there's a runway 18C FECON NOTAM. The VOR is out of service, a few things like that. I would go ahead and brief that our localizer frequency is 111.3 and our approach course is 183 degrees. Our runway landing zone is 10,000 feet. For myself, I only need 605 feet, so definitely good there. Circling is not allowed at night, and I would just note, some of the things in that box, like radar is required, DME or radar is required. Besides that, I would then note the minimum safe altitude for the area in case of emergency is 3,800 feet. We are going to have, looks like JEDCO as our initial fix. We need to be at least 8,000 feet by that point. After which we can descend to 7,000 by LERD, 6,000 by FIRSA, so on and so forth. I would give each one of those. And this is an ILS, so we will begin our final approach at glide slope intercept, not necessarily the Maltese cross. That glide slope intercept should be around silo, and we are aiming for 2,400 feet for that intercept point. After interception, we can descend to 942 feet with 2,400 feet of visibility, so about a half mile, I believe. In the case that we go missed, we'll have to climb to 3,000 feet on the Charlotte VOR 181 radial, and then proceed to the Denny intersection, which is 12.7 DME, and hold there. And the only thing I missed is when we get that glide slope intercept, we'll also start our timer. For myself, I'm usually going around 90 knots without any wind, so I'd be aiming for about 3 minutes and 20 seconds if I don't have any visual cues in order to go missed. That's when I can start going missed.
Awesome.
Those would be, probably everything I would brief.
Awesome. I love that. Oh God. I'm just going to go to Arizona. I don't want to find approaches near you because
yes.
I did all of my training over there. This is Vegas. A little bit more south. There's Phoenix. I hope they still have this approach. It's been so long. Oh, it's not going to let me. Oh, no, they got rid of that one. All right, let's see if Scottsdale still has theirs. Why is this a VOR DME alpha? Like, why is it not assigned a runway?
I believe it's not assigned a runway, like for the Alpha Bravo Charlie, is when there's not a straight in approach option. So it's probably more than 30 degrees off of runway alignment.
Okay. Yeah, that's it, right?
Be like circling only for that one.
Awesome.
Although, are there situations in which it's an Alpha or a Bravo, but it could be straight in?
Not that I can think of off the top of my head. You might be thinking of like the Yankee Zulus, the X-ray Yankees and Zulus down there on the other end of the alphabet.
Right.
Let me see if they.
I think I'm thinking of. I know that there's some approaches that have circling only, like minima, like it doesn't have any other minima. It's just circling, but it might be lined up with runway, so you just use the circling minima. But I can't remember if that was like an Alpha Bravo Charlie type or.
I mean, it might be. I don't see why that would be, that unheard of. I was trying to find another one, but that's the thing. I always just went up to this one. Because we've got, some RNAV DE, then we got some Zulus and Yankees.
And the Zulu and Yankees, those are just when there's multiple different types of approaches for the same runway.
Yeah, and I think it takes the minimums change based on which letter. So like the Yankee, the higher you go in the alphabet, or the reverser you go in the alphabet, the more backwards you go up the alphabet, the lower the minimums.
The reverser.
The reverser you go up the alphabet. I'm tired. So as you can see on the Zulu, we get 1637, and on the Yankee, we get 1580. Okay. Cool. Now, do you have any questions? I'm trying to make sure I touched on everything. But what questions do you have?
I want to double check really quick. Somebody from my school sent me some things that the DPE like typically hits.
Okay.
I just want to make sure I got everything. So we went over kind of the essence of flight planning and some of those decisions, like based off the charts and stuff. I feel pretty good with that. We went over Pitot-static. I feel like icing conditions is pretty straightforward, just knowing how to look for them based off of, your weather reports, winds aloft, and, your surface analysis charts and stuff. I guess radio failure is really the main emergency that they'll be checking for in IMC. But then, of course, like we went over all the like instrument failure options. I mean, if you have engine failure or electrical fires or something, then those protocols basically stay the same. You'll answer the way that you would with private pilot answers. Have you ever been grilled on like obstacle clearances for the sections of approaches? I feel like that's like within circling, for example, I think you get 300 feet of obstacle clearance within like the 1.3 miles.
I am going to have to look that up in the AIM, because that, you know what, that does actually sound like a really good, that is a really good question.
I feel like that's a big situational awareness thing I want to make sure is.
Yeah, let me dig up I was trying to see if I had it in my notes already. But let me dig up the AIM for the circling. I just go ask my wife. She probably knows. Where are we at? Air navigation. Yeah, I'm looking for that chart because I know that chart is in the AIM, the one where they break it down by like altitude and.
Yeah, I remember reading it somewhere in the AIM, like about getting like 500 feet clearance on like the intermediate segment versus 300 feet, I think, on the final approach segment. And I want to say it's 300 for circling. I want to say that was the only hearsay that I've heard this EP. I kind of want to make sure you're good on.
Mm-hmm. So circling approach, at least 300 feet obstacle clearance within the protected area. All right. So initial segment on the initial approach primary area, the minimum obstacle clearance should be, I don't think that's right. I think that's IASA, or I think that's international. During an instrument approach, what are the minimum obstruction clearances, initial, intermediate, final, ICAO, etc.? There's the thing, I'm finding the ICAO one.
Mm-hmm.
And it's saying 300 meters for initial, 150 meters for intermediate, and 90 meters for final. which would correspond. The FAA lays this out in order. What order is this? 8260.3 Charlie.
Okay.
So let me see if I can find it in here. All right. Straight in missed approach obstacle clearance. Within the primary missed approach area, no obstacle may penetrate the missed approach surface. The surface begins over the missed approach point. No, that's how they develop a missed approach procedure with that 40-1. That's not it. That's missed approach. It's all missed approach stuff. I think I might have found it. If you go to FAA order 8260.3 Charlie, and you go to figure 13-3-5. Here, let me just show you. Oh, wrong screen. Is this what you're referring to? Final approach and associated route obstruction clearance. So initial approach, 1,000 feet. Intermediate approach, 500 feet. Final approach, 250 feet.
Yes. I could have sworn that was in the AIM somewhere.
I think I know the circling chart that that you might be thinking of.
Mm-hmm.
But I found it. It might be in the AIM somewhere. Final approach associated route obstruction clearance. Trying to make sure there's not another place that I'm missing it.
Yeah, it also, I sometimes get confused about what I've seen in my school textbook versus what figures were actually from the AIM.
Mm-hmm.
Because I can almost visualize the chart that has the clearance.
All right. Obstacle obstruction clearance. No, that's not what we're looking for. That's minimum obstruction clearance. Obstacle clearance surface. No. All right. Utilize non-precision obstruction clearance used for primary runway to determine. No, that's just determining MDA. And it seems like this might be a little bit more about how the FAA is determining missed approach procedures and altitudes.
Right. That's okay. I think if it's not somewhere, I'll do a little bit of research on that anyways.
Yeah.
The only other things I guess I would ask is how much would you say you need to be able to articulate markers and be able to talk about categories for approaches? Like my plane, I don't think that it gives me the codes or the lights for outer markers, middle markers, inner markers. And, I don't really know if I can articulate much between like category 1, category 2 approaches and things like that.
Here's the thing. You're not cleared to do Cat 2s.
Right.
So why am I going to test you on something that you're not cleared to do?
Okay.
Like that would be like me saying, hey, tell me about how a turbine engine works.
Right.
Right.
Okay. I just want to make sure I didn't like need to be able to talk about that since it's on birch plate or.
No, because it's the thing. It's not like a Cat 2 approach. Can't do it.
That's all I need to know.
Can't do it. Right. Not authorized for Cessna 172. VDP might be another thing that some people bring up. Like, hey, what's a VDP?
It's basically just like the point where you should have the airport visually in sight in order to make a normal descent rate. After that, if you end up getting the airport in sight, you're going to have to descend beyond like a normal rate.
Yeah, that's
basically.
That's pretty much it. What was the other one that you brought up? So you brought up the I need to talk about Cat 2s?
Yeah, and then markers, like outer markers, middle markers, inner markers, because I don't even think that my plane shows the lights or the codes.
They show up in the audio panel. Have you ever here, let me grab an audio panel. Most of them do show up on the audio panel. Do you know what audio panel you've got?
I'm not 100% sure, unfortunately.
Okay. Well, I'll pull up this one just so you can see it, and maybe go take another IFR flight and just see. Because a beacon it's really just a beam that shoots up and you're flying through it, and it's hitting your airplane, and it's hitting it's setting off one of these lights. Does your airplane have something that looks kind of like this? The blue, the amber, and the white?
It might, and I actually just may have never looked at it, or it might not, and that's maybe why I've never noticed it.
You might just have it turned off too.
Right.
Right. I know my airplane's got them, but I to be honest, I use VOR cross radials instead of those things. If it's approved, of course. But now that the VOR is dead, I guess I got to make sure that these work. Now, what do you mean by articulate? Like, hey, they're a beam that shoots up. I'd read through the aim and make sure that you can get like maybe the size and know that like, hey,
like that.
I need how do I turn it on? Right. The outer marker is the initial approach fix. The middle marker is the final approach fix, and the inner marker is the missed approach fix.
Mm-hmm.
If I got that correctly. Yeah. Yeah, that's all I'd be really worried about.
Okay.
Because
and I guess I don't think I have too many other questions. Like I said, it had just been like a month since I finished the course, and I've been digging into study resources and stuff so much that I've gotten a lot in my head. And I'm assuming, there's still curveballs that might come up or things that I'm missing. But
and here's the thing that I've said to a lot of students is your instructor. This is going to sound rough, right? Your instructor doesn't care about you. Your instructor cares about pass rate and hours.
Right.
If you aren't going to get them any more hours and you're not going to screw up their pass rate, they're going to sign you off. But if you're going to screw up their pass rate, they're not going to sign you off. You've already passed this check ride. Another kind of takeaway is you've already passed the check ride once. Just go do it with a DPE now.
Right.
Right.
Yeah.
The level of knowledge you had, I wouldn't be concerned. You've got it. All right. Blown me out of the water probably more than I prepared for my own instrument check ride. If I'm going to be entirely frank about it, you kicked ass. The only takeaway I would have for you is a DP is not going to stop you from talking. They're going to let you go. And if you get to a point where you're like, oh, I don't know about that, they're going to go, tell me more. Okay. Yeah. I use the phrase never miss an opportunity to shut up.
Yeah.
Ain't nobody ever failed a check ride from, I can't really say that. Ain't nobody ever failed a check ride from answering the question appropriately and then shutting up. Okay.
Yeah. So just know when to stop talking. Don't go in every detail.
Yeah. Don't dig a hole. Don't go into every detail. You know, the joke I make is like DP asks you, do you know what time it is? And you say, yes.
Yeah. My first instructor did that. He asked me if I knew what this was. I spent like 2 minutes spinning my wheels.
Yeah.
And I said yes.
So just keep that in mind, right? If you ever see yourself, you know, kind of digging and talking and going. Also, if you're getting tired, take a break. Remember, it's your check ride, not theirs.
Okay.
If the weather is beyond your minimums, say no. Don't do it. Like, yeah, it sucks. You waited 3 months for a check ride. You waited 6 months for a check ride. Whatever, right? That is an external pressure.
True.
Okay, so just keep that in mind. But I would honestly say you kicked ass, and if you fail, I'll fight your DPE for it. No, I'm kidding.
That's okay.
I'm kidding, of course. Violence doesn't solve anything. But like, if you fail, I'd be genuinely surprised. Okay.
Okay.
As long as you know how to fly. I don't know anything about your flying skills.
Right. Yeah. I feel actually more confident about that. I mean, as long as I don't have a brain fart when it comes to holds, because I'm in the 6-pack. So like, you know, I have to like draw it and make sure I set it to the right radial and stuff. So I try not to do any mental math. Like, I used to pride myself in mental math. And for some reason, when I'm flying, like I can't even add 120 and 180.
Have you ever seen one of these?
Yeah, I don't have one though.
If you got time to order one, they're great. It has a holding like calculator in it.
Oh, cool.
Yeah, like here, and you can use it on your writtens too. So it is an amazing tool. Just bring spare batteries. DPEs will be like, oh no, it died. And you're like,
Right.
got spares. And they're like, shucks. I absolutely love this thing. I use it for my ATP CTP written, and game changer. Okay.
Yeah.
Not sponsored or anything, but the CX3 is where it's at. So
Okay. Noted.
But all right, man. Good luck. Let us know. This Discord has a bunch of other instructors in it. There's actually an instructor that just showed up a little earlier. He's a professor and a flight instructor. So
okay, cool.
He probably teaches a whole lot better than I do, to be honest. But if you got any questions, you know, shoot them into there's little channels up there, flight training questions. Some of those ones that you asked me where I'm like, God, I'm going to have to find that. Shoot them up there. Maybe somebody else will get it. I'll keep searching. See if I can find those answers. All right. There's a bunch of other student pilots in here. There's a bunch of other instructors in here that are all happy and willing to answer questions. All right.
Awesome. Yeah. This is the first time I had to download Discord for this. So I'll dig into it.
All right, man.
Awesome. Thank you so much for the time. I appreciate it.
Yep. Have a good day.